Good morning. Myself Dr. Syamala, working as assistant professor in the Department of Computer Science and Engineering in KL University. Now I am here to give a presentation on the concept of divide and conquer in the course Design and Analysis of Algorithm. So we have many design techniques in this course. One of such technique is divide and conquer. So it is an proposed technique which is having an algorithm that is already defined. So let me explain the principle of divide and conquer. So this principle is applicable for large problems. So where we will be using this principle to simplify the given problem. So coming to the problem. So initially whenever a given problem is given, so it is divided into two halves by applying a divide process, and then on each half, the first half and second half, so we will be calling the same process of dividing recursively on these two halves until we get a list of one element, and then internally in this process, so we will be combining we will be applying the merge process where it will internally combine, that means sort the individual elements and then return back as a two sublist, and then finally we have the phase of combine. So that will be having the merging of the two sorted sublist into one sorted list. So coming to the idea of merge sort, the same that is explained using a pictorial diagram. So given an array which contains n elements, so it is first divided into two halves, first part having n by 2 elements and the second half having n by 2 elements. And internally this first n by 2 elements are again recursively called using the same algorithm to make it or to divide until it has an element 1 in the list. Similarly the second part. So internally in this process, so each individual element, when by using backtracking, so it will combine and perform the merge operation, and we will get a two sorted sublist, and then on this two sorted sublist we will be applying the final combine operation, that is merge operation, to get a final sorted list. So this is the basic idea of merge sort using divide and conquer strategy. So there are two cases where you can apply this merge sort. One is base case. So usually if that list contains a single element, so nothing to compare, so nothing to sort. So in that case we need not apply this divide and conquer strategy. And the other case is we have more than one element in the list. In that case we need to apply the process of principle of dividing the list into two halves and then recursively calling the each divided list until we divide it into a list containing one element, and then combine the two sorted sublist into a single list using the merge procedure. So this is the algorithm for merge sort. So in this merge sort, so an array along with index value 0 and the index value n. So the index value low is denoted as low and the index value n is denoted as high. The starting value is taken as low and the ending value is taken as high. So initially we should make sure that list contains more than one element. So we need to check the condition if low is less than high. So if that is true, that we have a list containing more than one element. So what is the principle? So first we will be dividing the given list into two halves. By here we will be computing a mid value to make sure that we have the exact two sublist. So mid is equal to low plus high by 2. Then we will pass this mid value and low value to internally divide the first half by recursion, and then after we make sure that first half, that is the left sublist, is divided till we get one element in the list. Then we will go to the merge sort by dividing the right side list by calling mid plus 1 comma high. Once after we have these two sublist divided to one element, then we will call the merge process. Then in the merge process we will be internally combining the divided sublist, and then we will get a two sorted sublist, then finally this merge process is applied on that. So let me clear you the concept by taking an example. So the same recursive algorithm, so that merge sort algorithm what we have seen earlier. So let me draw a recursive tree for this algorithm. So let us assume that our list contains 6 elements. So starting from 1 to 6. The list contains 6 elements. So initially we will be passing the low value and then high value. So initially the index starts with 1, so the low value is taken as 1 and the high value is n, that is the 6. So we have more than one element in the list. So let me check the condition initially whether low is less than high or not. So as true, it's 1 is less than 6. So we can proceed, enter into the algorithm. So let me compute the mid value. So 1 plus 6 by 2, that is 7 by 2, that is 3. So the merge sort of low comma mid, so 1 comma 3. So this part will be recursively called until we get a list containing one element. So let me expand this list. Once after we call this merge sort ms of 1 comma 3, so again it will be calling the merge sort algorithm by passing the low value as 1 and high value as 3. So again it will check whether low value is less than high or not. As it is true, it will compute the mid value, low plus high by 2, that is 4 by 2, that is 2. So we are going to have ms of 1 comma 2 and so like this. So again it will call the merge sort algorithm, then it will come by taking the low value as 1 and then high value as 3. So 1 is less than 2, low is less than high, true, then it will compute the mid value, 1 low plus high by 2, that is 3 by 2, that is 1. So ms of 1 comma 1. So we have a list containing one element. So one element in the list. So there is no further division. Even if you are again calling the recursive algorithm by taking the low value as 1 and high value as 1, so we will be failing to enter into the loop of division because low is less than high condition gets failed. So in that case, so we will come to the next step, that is, so if low is less than high, then first we have divided the first half until we got the element 1. So low comma mid, low plus high by 2, and then this process is completed. So we have the list containing one element. Then we will go to the next step, that is ms of mid plus 1 comma high, right? So we will backtrack. So here we will backtrack. So ms of 1, so here the mid value is 1, right? So 1 plus 1 means 2, 2 comma high value is 2. So ms of 2 comma 2. So here also we once if it is executed, once again if the call was made to the algorithm recursively, so here the condition failed because 2 is less than 2. So that is, this is the end of the list. That means only single element is there in the list, no further division can happen. So then it will come back to the merge, the third process, merge of so low comma mid comma high. So here what is the low value? 1. Then what is the mid value? 1, and the high mid value and high value is 2. So ms of 1 comma 1 comma 2. So this is one part, sub part that applies the process of merging. For example, I have a list containing elements like 9, 6, 5, 0, 8 and 2. So internally first the list is divided into two halves, that is 1, 2, 3 is into one part. So that means 9, 6, 5 comes here, 9, 6, 5 comes here. Then so again it is internally divided by 1 comma 2, that means 1, 2 comes to the left part and then 5 comes to the right part. Then ms of 1 comma 1, that means first 9 comes here, then ms of 2 comma means second element in the list 6. So whenever I have this ms of 1 comma 6 containing the list of elements like 9, 6, 5, 0, 8, 2, it is divided into half, that is 3 elements 9, 6, 5, and then it is internally divided into half, that is 9 comma 6 into one list and the 5 into another list. Then this left part is again divided into half, that is 9 and then 6. So once we come here, so we will apply the merge procedure M. So merge procedure, let me denote it as M. So merge procedure have 2 elements, that is 9 and 6. So I am going to take this as low value, this is mid value and this is high value. So what does this merge algorithm do? So we treat that, so we have 2 arrays and 1 array to store the final result. So in the first array we have element 9 and the second array we have an element 6, and we have 2 pointers, I pointing to the first array and j pointing to the second array. So we have an empty array, that is k, this is array A, this is array B. So if you need to write a logic that, so by comparing if a of I is less than you take b of j. So if a of I is less than b of j, that means if you find that element in the array is less than the element in the array B, then you need to push that element into the k array. So but here in this example, which is smaller value, so b of j is smaller value, that means we will push first b of j value to the k array. Then we will be incrementing, this is the k pointer, let me take this array as a C. So we will be incrementing this k value, and then whatever element we have considered or pushed from an array, so that pointer will be incremented. So that means j comes to plus 1. So I is still residing at that first location. So there are no elements in the B array to compare with the elements in the A array. So then we will push whatever the elements that are there in the A array direct into the empty array. So the sorted list will be 6 comma 9, and that value will be stored in this M of 1 comma 1 comma 2. So M of 1 comma 1 comma 2 contains 6 comma 9. So then we will backtrack, and then again we will call this process of this merge sort of mid plus 1 comma high. That means we will be expanding the right part. So mid plus 1 comma high is the right part of ms of 1 comma 3. So here we have let me write this left part. So ms of here I got the mid value as 2, so it will be 3 comma and high value is also 3. So at 3 comma 3, ms of 3 comma 3, I have only one element, that is 5. ms of 3 comma 3 is 5. So this 5, let me make it clear. So ms of mid plus 1 means 3 comma 3. So ms of 3 comma 3, so we have only one element, that is 5. So whenever we get this, again we have we again recursively call this at that condition mid less than, low less than, high will be failed. Then we will be getting ms of m of low comma mid comma high. That means here we will be having m of low value is 1, mid value is 2, and the high value is 3. That means we are merging m of 1 comma 2 comma 3. So that means we got a sublist by merging m of 1 comma 1 comma 2, that is 2 element list, and we will backtrack here and we have an element 5 here. So these two sublists are given to the merge algorithm for performing the combine operation. In the same process how I explained here, so the process will be continued. So I have two arrays, that is one is 6 comma 9, which is already a sorted sublist, and one more array containing list element 5. So I will be pointing to the first and j will be pointing to the first element in the B array. So we have an array C to store the result, and then we have a pointer k pointing to the starting location of array C. So we will compare whether a of I is less than a of b of j or not. So by that we have b of j is smaller value, and then that is the end of the array. So whatever elements that are there in the A array you directly can push, because it is already a sorted sublist, so we need not compare the next element with the previous element. So this is the final result that we have at m of 1, 2, 3, that is 5, 6, 9. So in the same way, so the right side part also will be expanded. That is, the right side part contains ms of mid plus 1, 4, 4, last element is 6. So by the end of this merge process, so we have, so ms of 1, 6, so is divided into ms of 1, 3 and ms of 4, 6, right? So from this ms of 1, 6, I will get a sorted sublist having the element 5, 6, 9. And the same way, if applied on the right side part, the same backtracking process, so I will get the elements like 0, 2 and 8 based on the input I have considered here, 5, 6, 9, 6, 5 and 0, 8, 2. So on these two, this is my first part and this is my second part. This is my second part. On these two are nothing but sorted sublist. How they are sorted? By recursively calling the merge algorithm and then applying the combine operation on the divided sublist. So this is the sorted sublist. So on this again we will be applying the merge or combine operation to get the final sorted sublist. So the same process. So this is an array A, so this is an array B. Array A contains pointer I, j, and this is some new array C to store the resultant results. So compare, so 0 is less than 5, so push first 0 and then increment the pointer here. Then 2 is compared with 5, so 2 is smaller than 5, so push first 2, then you are pushing 2 here, so increment the pointer 8, so 8 is compared with 5, so 5 is smaller, so increment the pointer here, then 6 and 8, so 6 is smaller, so increment the pointer here, then 9 and 8, so 8 is smaller, so increment the pointer, so it is the end of the list, so whatever element there here, so you will push directly into the resultant array. So the final sorted sublist is 0, 2, 5, 6, 8, 9. So this is the process behind the merge process using the divide and conquer principle. And I hope this is made clear. The same process of dividing and then recursively calling the algorithm and then applying the merge process is been explained here with an example, animated example. So initially the list contains totally 8 elements. So first initially it is divided by calling the merge sort algorithm. So it computes the mid value. So 1 to 4 is divided into first part and then 5 to 8 is divided into second half. So internally A of low E value is 0 and high value, mid value is 3. So then again it will call the merge sort algorithm. So again it will be comparing these 2 and 6 and then it will sort it, and again the resultant is sent back to the merge of A 0, 0, 1 results in the merge of the two sorted sublist. The same thing what we have discussed with the recursive tree is applied on this example. Then we came to the merge sort of mid plus 1, high, that is the right part. So that is applied on the two elements, that is 8, 4, and then it will internally divide and then again merge and then give back as the result as 4, 8 at merge of 2, 2, 3. So we have the two sorted sublist with using 4 elements 2, 6, 4, 8. The same is done with the right side sublist also. It is divided there. Then we got internally sorted that right side sublist and both are given to the merge algorithm, which will internally perform the sorting operation. So this is the tree call. So what we have discussed orally in the notepad, the same thing was given here. So this is the merge process. So two arrays, A array contains a given list of elements. So previously I have taken as 3 arrays, but in this example they have taken as 2 arrays. One is to store the result and one is the given list of elements. So in the array A, they were divided into 2 halves, from low to mid into one part and mid plus 1 to high into other part. So initially 2 pointers they have taken. So I pointer is pointing to low value and J pointer is pointing to mid plus 1 value. So I is pointing to low value and in this mid plus 1 is pointing to J value. So both were compared and whichever is the less value, it will be pushed into the resultant array. And then wherever we pushed, that a pointer will be incremented. So like that we will be applying the merge process. The same thing was given in the algorithm. The comparison of the low value with mid plus 1. If it is low, whichever value is low, we are pushing that into the resultant array. So coming to the time complexity of merge sort, so we divide the given list into 2 halves. So that means to sort the first merge sort, so that is from low to mid, it will take T of n by 2. Similarly, to sort the second half, that is mid plus 1 to high, so it will take T of n by 2. And we have a merge process, right? So in order to execute that merge algorithm, so merge algorithm is applied on the whole n elements. So the total time complexity is T of n by 2 plus T of n by 2 plus n, 2T n by 2 plus n. So if this case is true, if low value is greater than high, so that's why n is greater than 1, more than 1 elements are there in the list. So in the other case, it will be executed for some constant amount of time, generally it is 1 or n. So coming to the time complexity of merge sort, so if you solve the this recursive equation using either substitution method or a recursive tree, so we will be getting a time complexity order of n log n. So this is the computation here. So let me explain that also. So we have T of n is equal to 2T of n by 2 plus n. So let me solve this recursive equation using substitution method. So substitute the given equation 1 with n by 2. So then, this is the process of solving a recursive using substitution method. So if you substitute this T of n with T of n by 2 in the given equation, it will be 2T of n by 4 plus n by 2. So let me take this equation as 2 and similarly make one more equation by substituting the given equation 1 with T of n by 4, then it will be T of n by 8 plus n by 4. So this is equation 3. Now in the given equation 1, substitute equation 1 with equation 2. That means wherever you have n by 2 term, you substitute that with the equation 2 in the given equation 1. So that is T of, only T of n by 2, only this part need to be substituted. Then T of n by 4 plus n by 2 plus we have one more n, right? So write it as it is. So it will be 4T of n by 4 plus 2n by 2 plus n. So this 2 gets cancelled, and now substitute equation 3 in the above equation. So because we got a term in terms of n by 4, right? So we will be substituting the T of n by 4 with the equation 3. Then it will be T of n by 8 plus n by 4 plus this n plus n is 2n. So now it will be 8T of n by 8 plus 4n by 4 plus 2n. So this 4 and this 4 gets cancelled. Now I have 8T of n by 8 plus n plus 2n, that means 3n. Okay, I can write this in terms of T like 2 cube into T of n by 2 cube plus 3n, right? So let me assume, because to compute the time complexity we need everything to be represented in terms of n. So I can make this equation with some constant like T of n by k by n of k plus k into n, by substituting that value of 3 with some value k, constant k. So as I need to get the time complexity in order of n, so let me assume that n is equal to 2 power k and apply logarithm on both sides. So log n is equal to log 2 power k. So log n is equal to k. So we can get the power to the based on the principle of logarithm. So this value is 1. So I can substitute the k value with the log n, right? And n value with n power k. So let me substitute these two values in this equation. So then let me see what is the resultant value. So 2 power k means n, then T of n by 2 power k means n plus k value is log n, right? Log n into n. So we have kn. So k value is log n and we have one more n. Okay. So this value will be T of n into T of 1 plus n log n. So based on the given recursive equation, so we have T of 1 value as 1. So n plus n log n will be the final answer. So in order to compute the time complexity, we will be considering only the terms that are in higher order, right? So among these two terms we have n log n is the highest order term. So the time complexity for merge sort is n log n. So this is in case of best case, average case and worst case. So thank you.